Hi everybody, welcome to another continuation video of solving problems on torque, and this last one is when you have two pivots. So let me just demonstrate the setup to you, and in order to do that, first of all, I have over here a meter ruler that I have put on two supports. So the mass of this meter ruler, if I put on a weighing scale over here, is about 80 grams. Okay, so the meter ruler itself is 80 grams, and the mass of that meter ruler acts towards the center. I have purposely not put the supports at the very edge. So there's this support which is 10 centimeters from this side, and the other one is also 10 centimeters from the other side. So the supports offer an upward force. The mass of this ruler acts through its center through the 500 gram mass. Now usually when you have questions with two supports, you'd have some sort of an object on it. So you could have somebody sitting here or here, anyway. Now just to get my distances accurately, I have put a thread here, and I'm just going to add some slotted masses. So just to keep it simple, so I've got 350 plus the mass of the stack itself. So each one is 50 grams. So that makes it 200 grams, and I'm just going to put it there. Now suppose this 200 grams acted through the center, so it's at the 50 centimeter mark. The forces acting would be the mass of this itself and the mass of that, all through the same center. So these two support forces will be equal because they're equidistant from here. However, this doesn't have to stand at the center. If I move the mass to one end, you're going to see that this one has to offer a greater support compared to the other one. If I move the mass to the other end, then this support has to offer greater force. So how am I going to calculate this? So let's just get the support at one end. Whenever you calculate this, it's quite easy if you name one support force as A, and if you name the other one as B, because it just gives you something to refer to. Now in order to do this, we actually consider one of the two as a pivot, okay, around which it turns. So you just do one pivot at a time, doesn't matter which one you choose, just choose one of them. So let's consider A as a pivot, and let's just get some nice numbers. So let's say this one is at the 300 centimeter mark, and A is 10 centimeters from there, B is 10 centimeters, and this is about 80 grams. That's 200. So just knowing the numbers, let's just solve the problem. Over here, I might just rub off some of the previous ones to make me some space on the board. So we've already done these. So this is what we're looking at. Okay, so what I have here is this whole thing is 1 meter. This distance is 10 centimeters. This distance is 10 centimeters, and I'm calling one of them pivot A, and the other one I'm calling B. And I had a mass that was 30 centimeters from the end, which is 20 centimeters from A. So I'm just considering A as a pivot. So there's a mass over here. So that was 200 grams. So it's 200 times 0.8, and the mass of this was 80 grams, so 0.080 times 9.8. Now those are your downward forces. In addition to this, you're also going to have the support force from A and the support force from B. They're not going to be equal because the mass is on this side. We are trying to find out what's each of these. Now, in order to do that, we consider A as pivot. So taking A as pivot, at equilibrium, we know that the total clockwise torque equals total anti-clockwise torque. So that's clockwise, that's anti-clockwise. To figure out what's the torque, this is my pivot. So I've got clockwise, 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 and it's going along there and goes up in the direction of the arrow. That's anti-clockwise. So when I am writing, so I've got 0.200 times 9.8, and that distance there, this distance, this was at the 30 centimeter mark, so it was 20 centimeters, okay, times, okay, just leave it as centimeters if you want, so it's 10 centimeters all the way through, and then we've got one more, so that's anti-clockwise over here, through here, okay, plus, this is at the 50 centimeter mark, but it's only 10, so it's 50 minus 10, which is 40 centimeters. Okay, so I've got 0.080 times 9.8 times 40 equals, we don't know what is FB, and the distance is not a whole meter, but this is 10 centimeters away, that's 10 centimeters away. So the distance from here to here will be 80 centimeters. So times 80. So because I'm getting the force, I'm not going to cancel the 9.8. So I've just got to get the numbers into the calculator. So I'm going 0.200 times 9.8 times 20 centimeters, and I get 39.2 plus 0.080 times 9.8 times 40, and I get 31.36 is equal to 80 FB. So 31.36 plus 39.2, I get 70.56 is equal to 80 FB, or my FB is 70.56 over 80. So if I divide that by 80 centimeters, I get 0.882, but I want the force, so ideally, yes, so the force is 0.882. 0.882 newtons. Okay, that's upwards. So if I want, what is the force? This is the force exerted by FB. FB is on that side. So in order to find FA, I know total force up equals total force down. The total force up is FA plus 0.882 equals, now what is 0.20? So it's this force down and that force down. The force is 0.200 times 9.8 plus 0.080 times 9.8. So let's find out what that is. So 0.200 times 9.8 is 1.96. So you get 1.96 plus 0.080 times 9.8 is 0.784. 0.784. When I add these two, so this is FA plus 0.882. See what I'm writing? Let's just put that down a little bit. Yeah, so you can see. Okay, so let me add these two, and then from that I need to subtract this. So 0.784 plus 1.96, I get 2.744 minus 0.882, and I get 1.862. So FA is 1.862 newtons, and that's upwards. So can you see that's my FA, that's my FB, and FA is bigger than FB simply because it has to support that mass there. And I hope that helped. Bye for now.